Driving while under the influence of alcohol can be deadly. Police officers often administer a sobriety test to any driver suspected of being drunk and will arrest the driver when the blood test results exceed the legal limits. The age, in years, of 30 drivers arrested and charged with DUI on the night of February 14th in a recent year are as follows. Construct a well-labeled relative frequency histogram. Okay, so we're going to create a histogram. That means we should first decide on the bins. We need a bin size, and we need a minimum and a maximum for our bins. So first things first, we'll look at the data and pick a maximum, or find the maximum and the minimum values. So a quick scan of the data turns up 21 for the minimum. I don't see any numbers less than that, and it looks like 58 is the maximum. I don't see anything greater than 58 here. So all the data are between 21 and 58. So I think for a minimum and a maximum, we'll use minimum. We can use 20. So make a nice multiple of 10, and a maximum for our bins, we'll use 60. So the range here, the bin range, is 40. Okay, and 40 divides nicely by lots of numbers, so we can pick a number of bins equal to many different things. So we can have 5 bins, 8 bins, 10 bins, 4 bins. I think what I'll do, I'll choose a bin width of 8. So we end up with 5 bins. So 5 bins means we take the bin range, divide by 5, and that gives us a bin width of 8. Okay, so starting with 20, starting with our minimum, our bins are therefore 20 to 28, 28 to 36, 36 to 44, 44 to 52, and 52 to 60. And now we have to decide before we go any further, in which bin is the 28? Is it in the first bin or the second bin? And I'm going to put a little mark here. We're going to include to the left. That is, at every boundary between 2 bins, we'll include that one in the lower bin. So the 28 is in the first bin, but not the second bin. The 36 is in the second bin, but not the third bin. And so on and so forth. We'll always draw the intervals this way. Okay, and now we count the frequency. So we have to go through the data, make a tally chart, 20 to 28, 28 to 36, and we're going to go right through the data. 49 belongs in this bin. 34 belongs in this bin. 53 belongs in this bin. 23 belongs in this bin. 31 here. 32 also here. 21 here. 26 here. 40 here. 55 here. 24 here. 29 here. 26 here. 26 here. 38 here. 37 here. 22 here. 22 again here. 45 here. 46 here. 27 here, 32 here, 51 here, 30 here, 53 here, 54 here, 56 here, 58 here, 38 here, and 27 here. So even though I made a big deal out of the fact that 28 would be included here but not here, 36 would be included here but not here, none of the data actually ended up being on one of these boundary points. Had we had a 44, we would have had to put it here, not here. So it would have gone in the third bin, not the fourth bin. So just something to keep in mind. And now we can count them up. So frequency, we had 10 in the first bin, 6 in the second bin, 4 in the third bin, 4 in the fourth bin, and 6 in the sixth bin. So we now calculate relative frequencies. And since there were 10, 16, 20, 24, 30, I believe it said that, 30 observations, the first relative frequency is 10 over 30, or approximately 0.33. The next one is 6 over 30, which is exactly equal to 0.2. 4 over 30 is 0.13. 4 over 30. 30 again is approximately 0.13. 6 over 30. So our relative frequencies look like this. And finally, we get around to drawing the histogram. So we will put a title, ages of drivers caught driving under the influence of alcohol. So under the influence. And our frequencies range from 0 up to 0.33. So on the range here we'll put up to 0.4. So that's 0.2, 0, 0.1, 0.3. So we have 0.1, 0.2, 0.3, 0.4, and then for the ages we have 20 to 28. So I'll start to make the bars here. 1, 2, 3, 4, 5 bars. So the first bar will represent 20 to 28, or 20 to 28, including both endpoints. Then we have 28 to 36. That should be a comma. Then we have 36 to 44. 44 to 52. And finally 52 to 60. Okay, and the 20 to 28 bar should have a relative frequency of 0.33. So we put that bar in up at around 0.33. Next bar is up at 0.2, relative frequency of 0.2. Then we have 0.13, which is roughly here. Another one at 0.3. And finally, the last one is also 0.2. So the last thing we should do is label the y-axis, that is relative. The relative frequency.